Algebra Unit 9, Lesson 3, Square and Cube Root Graphs, Notes in Video 3. A radical equation is an equation that contains a radical with a variable as or in the radicand. Similarly, a square root function contains the square root of a variable. Square root functions are a type of radical function. So we know functions. Now we're using the word radical as we're going to have the square root symbol inside the function. All right, so just going over this first key concept. The parent function for radical functions is f of x, that's our function notation, equals the square root of x. The type of graph that it makes, well, it's going to make kind of a curve. So notice this blue line here is that kind of curve. The domain, well, since we're doing principal square roots, we should not have any negative answers or negative results. So our domain, or our x values, should be starting at 0 and getting positive, going towards positive x's, no negatives. Our range then is our y values. So here we're starting on the y-axis at 0, and again we're increasing, we're getting to positive y values. So again, our domain is greater than or equal to 0, and our range is greater than or equal to 0 as well. All right, letter A, for each square root function, graph each square root function and determine its domain, range, and end behavior. All right, so the first thing I want to do is go back to way back when we first started graphing, and let's make a table of values. So I'm going to slide over here, and I'm just going to choose to do a t-chart, table of values for x and y. And I'm going to choose some easy numbers. So my goal is to get the square root of x. So I'm going to think of numbers that I'll get a nice answer. No decimals, no rounding, just a nice answer. So first I'm going to pick x is 0, x is 1, x is 4, and I'll go up to 9. Now I'm going to plug that into the rule, the square root of x, and get my output. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So that's kind of like step 1. I'm going to make a chart or a table. Step 2 is I'm going to plot those points. So I had 0, 0. I had 1, 1. And then I had 4 and 2. And then let's see if 9 will fit on here. It will not, so I'm going to end with those 3. So I really can't, I can still leave that in my table, but I can't graph that one. But I have 0, 0, 1, 1, and then 4, 2. So my second step then is to draw a smooth curve connecting those points. So I'm going to zoom back in, keep my color red, and I'm going to draw a smooth line, best I can, connecting those points. So the word smooth line, that means with your free hand, no rulers, so it's not going to be perfect, but it should look very similar to mine. So please do the same 2 steps. Make a table of values, pick x values that will fit on the graph as best you can, find the output for those. All right, so the domain. It looks as though, again, because I'm taking square root, I should have all positive numbers here. So the domain, and if we go way back a few chapters to put this in our proper notation, we're going to start with a brace x such that x is greater than or equal to 0. And our range then is y such that y is greater than or equal to 0. All right, so now here's the kind of a new piece, but not too difficult here. Tell me about the end behavior. As x increases, what happens to y? So again, you're looking at a 2-dimensional picture here as x increases. So here is x, here is y. So as x is getting bigger, so as I'm going this way on the x-axis, what's happening this way? Well, hopefully you can see that as x increases, y increases. Okay, now let's also talk about as x decreases. So now we're almost coming back this way. As x is decreasing, what is happening to the y? Well, as we're coming down this line and x is decreasing, y is also decreasing. Now, you don't have to draw, a little bit neater, you don't have to draw those lines on your graph over there. I'm just doing that so you can hopefully visually see it. All right, so whenever you're asked to graph a function, especially when it's not linear, but even if it is linear, start with step 1, make the table of values. Step 2, connect your points with a smooth, nice curve. Letter B. Y equals the square root of x plus 4. So I'm going to do the same thing. I'm going to start with the table of values as my step 1. And I'm picking random values of x, but not so random. I want this answer, the output, to be a not decimal. I want it to be a nice, easy number. So I need to, so I'm going to start with 0 again, 1, 4, and see if those will get me good answers. Now if they don't, then I extend my graph. So the square root of 0 is 0, plus 4 is 4. The square root of 1 is 1, plus 4 is 5. The square root of 4 is 2, plus 4 is 6. So let's see if I can graph those three, and if so, then I think that'll be enough. So I have 0, 4, I have 1, 5, and I have 4, 6. I'm going to connect those with a nice, smooth, easy curve. Alright, so there we go. So domain and range. So it looks as though domain, again, I'm talking about my x's. So x-axis. So it looks as though my domain starts with x is 0 and increases. So again, I'm going to use the brace x such that x is greater than or equal to 0. Okay, range of the y values. So where am I starting on y? Well, I'm starting at y is 4. So at y such that y is greater than or equal to 4. Okay, right now in my end behavior. As x increases, what's happening to y? So as x is increasing, what's happening to the y? It's also increasing. Okay, as x decreases, what happens to y? So as x is decreasing, what's happening to the y? As I'm coming down this x, what's happening to y? Y is also decreasing. And one other thing I want to mention here, that as x decreases, as x is decreasing, so we're going as x is getting smaller, so big X is smaller, x is smaller, it is true that y is decreasing, but is y approaching a certain number? Y should be approaching 4. Now remember, we can't have negatives with as radicand, so if I was to say, well, let's go over here and put a -1, we are so far in our mental abilities with math, we are unable to do square roots of negatives. So we can't have that negative over there. So as x decreases, y decreases, but it also approaches 4. And it's a positive 4. All right, on the back, I'd like you to try C on your own, and we'll come together and do D. First thing again I'm going to do is make a table of values. Again, I need to pick good numbers for x. Again, whatever you want, but again, so that the function works out to be a whole number. Again, we don't want decimals here. So I need numbers that will get me a cubed root. So I'll just start with the easy ones. We'll do 0. The cubed root of 0 is 0. Let's do 1. The cubed root of 1 is 1. our next number then would have to be all the way up to 8. The cube root of 8 is 2. Let's see. It can go 8, so that's good. But remember now, for cubed roots, you can have negatives as radicands. So I'm going to extend this a little bit more and get some negatives in here. So let's do -1 and -8. So the cubed root of -1 is -1. The cubed root of -8 is -2. So now I have 5 points. This should be pretty good. So first I have 0, 0. We had 1, 1. We had a -1, -1. And then we had 8, 2. And then we had -8, -2. So the graph of a cubed root, so step 2 then is to connect your line with a nice smooth curve as best you can. So your cubed root of x should look like that. Alright, now let's talk about our domain and range. So our domain, again, is our x values, and our range is our y values. So, alright. So, it looks like I'm going to have positive and negative x values. And do I have, like, all of them forever? The arrow goes on forever, and I'm continually going up. The arrow here goes on forever, and I'm continually going down. So it looks like x such that infinity is less than or equal to x, which is less than or equal to infinity. Oh, negative infinity. Our range is our y values. So it looks as like we're in the middle of 0 here. We're going up on y and down on y. So it looks like the same. Alrighty, now we talk about the end behavior. So as x increases, what happens to y? Well, x is going up here, increasing, and y is increasing. X is going down here, and y is also decreasing. Alright, letter E, I'd like you to try on your own. It is very similar to D. The only change is that you have a negative out front and you have more happening within the radicand. Again, you can account for all of that. Don't get frustrated. If you start with the table of values, you will do much better. Even if it takes you a few minutes, that's okay. Alright, so the last problem on the last page, probably our most difficult one. Solve the equation, the cubed root of x plus 2 equals -1/3 x plus 4 by creating graphs. Okay, so first, we have to use the graph because it tells me clearly that I have to create the graphs. But let's also think back to where this comes from. So it looks like we have two completely different equations or two completely different functions. So maybe let's start by writing those as such, as two different functions. So our first one is going to be y equals the cubed root of x plus 2. And the second one is going to be y equals -1/3 x plus 4. So this looks like a system of equations from a few units ago. That if both of these equal y, then their counterparts must equal each other. And that's how that huge, scary-looking equation was formed. So what we really want to do is graph these two things independently. So first, I'm just going to graph the one that I'm more familiar with, that hopefully you remember how to do, the linear function. So this one here is the linear function, because there's no square or cubed root, anything like that. So this is in the form y equals mx plus b, where we begin with the b and we move with the slope. So we're going to begin at +4 on the y-axis, the y-intercept. And now because we have a negative slope, we're going to go down 1 and over 3. Make those a little bit nicer. And we're going to do it again, down 1 over 3. And I can't fit another one that direction, so that's okay. I'm going to maybe go the other way, just so I have no idea where these two lines are going to intersect, so I'm going to show all of that. So up 1 and over 3. Up 1 and over 3. Okay, so now I'm going to get out a ruler, which, yes, you of course have to use rulers. And connect these points. Well, we need to use a ruler whenever we're using a linear function. Line this up the best you can. Keep my line green. I'm going to again add arrowheads on the ends, both sides. And I'm going to label this. So all that review from a few units ago still comes into play, and that's the great part about algebra is we don't just do something, learn it, and forget it, or memorize it and forget it. We have to truly learn it and apply it. So there's our first one done. So now we have this one that is more the normal for this unit. So I'm going to start with a table of values again. And I'm looking for cubed roots when I have x plus 2. Alright, so I need to get a perfect cube by adding 2. So let's start with, and again I can have positive and negatives. So when I add, I'm going to start with positives first because that's way easier. So the cubed roots that I know are 1. So in order to get a 1 from the inside here, I need to subtract 2. So well, I'll start with that one since it's the easiest. So negative 1 plus 2 is 1. The cubed root of that is 1. Okay, the next cubed root that I know besides 1 is 2 times 2 times 2 is 8. So I need to get the radicand to be 8. So I need to take 2 from that, so 6. And I'm going to plug 6 in. 6 plus 2 is 8, and the cubed root of 8 is 2. I can't really go much higher than 6, so I'm going to let that be. Now maybe let's see if I do, I need, let's do negative 8, so let's say negative 10. Negative 10 plus 2 is negative 8. The cube root of negative 8 is negative 2. Alright, so there's a few points. I really can't even fit all those in here. But let's start by plotting those. So negative 1, 1. Right there. And 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. Be there. And negative 10, negative 2. I can't fit that on here. So maybe at this point I would check my graphing calculator, plug those two both in. Okay, it looks like I'm going to need another point. So another cubed root I could do is 0. So if I plug in a negative 2, negative 2 plus 2 is 0, and the cubed root is 0, so there's my third point, which makes this much easier. So negative 2, 0 is right there. And I'm also going to do negative 3. Negative 3 plus 2 is negative 1. Cube root of negative 1 is negative 1. So that gives me one more point. That way I can just see where the curve is going. Otherwise I have this half curve, and if you remember, cubed root should be some kind of a line like that. So we want to get more points in here. Negative 3, negative 1. And I can't fit the negative 10, so I'm just going to curve this up nice and slowly. And then this is going to continue down here. I don't know exactly where, but again, that's still a pretty good estimate. So solve the equations by graphing. We have, where is the intersection of these points? It is at positive 6, positive 2. Now, for those of you that don't like graphing, I'm sorry, you had to graph it. But eventually, we can also solve this system by substitution or elimination. So just keep that in mind again. We're just building every day, using and applying everything we've learned all year.